All right, on today's episode of Python Papi, we're back inside our Tensorflow course, and we're still doing our human emotions detection module. Let's have a look at what we went over today. And we're still inside our ResNet module. And yesterday, if you recall, we went over the partial derivatives and how it'll change to the partial derivatives is so small it doesn't actually affect our weights. So we're going to pick up where we left off from that. So now we're seeing that making our network deeper or increasing the number of layers makes it difficult to propagate information from one far end to the other end. And so what the author supposes that if the added layers can be constructed as identity mappings, a deeper model should have a training error no greater than its shallower counterpart. This means that if we have a shallow model and a deep model, we can construct the deep model in a way that it is identical to the shallower model. Let's look at the examples below of the shallow and the deep model. So you can see here we have the two models, the shallow model and the deep model. Now, really, in essence, the deep model is larger than the shallow model, but it's constructed in a way that the only parts that are going to count is the part that is identical to the shallow model. The rest of it is going to be classified as an identity or identity function. So basically, the two areas of the shallow and the deep models are identical, and the extended piece of the deeper model will be classified as the identity function or a group of identity functions that get stacked together. This way, the training error of the deeper model shouldn't be greater than the training error of the shallower model. So, like I said, because this is larger, we're just going to extend this extended piece is going to be classified as an identity function or a group of identity functions. And this section here is going to be identical to the shallow function, so it shouldn't be a greater error than this shallow function here or than this shallow model here. So basically, we're really only counting this piece of the deep model, and the rest is getting classified as something else. So we're not going to classify it or get it involved in this, inside our error training. And let's see what else we And so this means that if we want to pass information from one point to the point in our residual block, this path permits us to copy the input to the output. See lines 169 and 177. And that's going to look like this inside of our residual block, 169 to 177. And you can see here, this part doesn't really count, this extended piece. This is the part that's actually getting classified as our identity function. So basically, that's all we went over. Like I said, it did take me a while to get this concept down. I had to go over it a few times before I understood what they were saying. But now that I do understand, you're able to move forward. So basically, like I said, even though the deep model is larger than the shallow model, only this portion of it is going to be counted or mapped together with this shallow function here. The rest of the deep model is going to be classified as something else. So we're not going to involve it in the error training. So that's how it's able to make things work. But of course, we are going to keep moving forward now that we have some understanding, and I will keep you posted every step of the way. But for now, it's the Python Poppy. You guys stay Gucci.